Hi everyone, this is Renee, and I am just wanting to kind of give you an update on where I am with the Atlanta Crime and Data and Astrology project. A few days into it, and came across some snafus, but nothing that's not handleable. So first, I want to show you where I got this data. Is from this web page, and the link is below the video on YouTube. And yeah, uh, the link will take you to this page. And what I got was this file here down at the bottom, Cobra 2009 to 2017, updated as recently as September 13th of 2018. Um, Let me show you the code sheet. Um, what the data gives is code as well as like location, latitude and longitude, um, and type of crime. And here I'll show you an example. Um, Here's an example here. Uh, so the first entry is report number, then report date, then occurrence date, then occurrence time, possible date, possible time, location, and most importantly, this UCR number, which is a code for the type of crime. Um, and so if you go back to that Atlanta PD page and click on UCR code sheet, you'll get this, and you'll see that, say, the homicides are all in the 100s. Rape is 200, robbery 300s, all the way up to motor vehicle theft, arson, fraud, forgery, vandalism, etc. So the goal for this project is to see um, if there's something that very simple astrology, namely the degree of the midheaven at the time and place of the event, as well as the sun position and moon position, can be a better predictor than just the date and time itself. Because there does seem to be some time dependence, at least for total counts of events, that there's a rise and a fall, and then another rise, another fall, um, with about mid year being the peak. So that's hot summer. I think it's pretty well known that crime goes up in the summer. So there's this nice umbrella shape that I referred to last time. There is a slight decrease over the course of the years, starting 2009, ending 2017. There's an ever so slight sort of downward trend of the umbrellas, if you will. And then there's this crazy thing here. I'm not even sure what that's about. It's just over halfway through the data, just uniform increase. So I don't know if there was a new, uh, you know, uh, person, personnel in the department where they radically increased their reporting or what. But this is the data that we have. Um, so what I found, to just kind of catch up to where we left things last time, is that I was able to get the midheavens successfully, but I was not able to use the built-in Mathematica program to get the right ascensions for the for the sun degree, and similarly for the moon degree. There was all this, like the server was down or something. So I didn't know if that was permanent or temporary. At the time, I think I assumed it was a permanent thing, and that I just would not be able to get over 320,000 event uh, degrees directly through the built-in um, sort of feature of Mathematica where they can get you the right ascension for this sun, and similarly for the moon. But just that one day, it just wasn't working, and so I thought it was permanent. But I tried again just this morning, and it seems to be working here. Uh, Same code as over here, but I just tried it again, and it's working. So yay! Maybe there's an issue with the server the other day, but I didn't know that. So what I decided to do was to also get sun and moon degrees from a lookup feature online from NASA called the WebGeoCalc page. So let me show you how that works. It's good for anyone to know, I think, astrologers to know how to use WebGeoCalc. So if you go to this URL, and I'll put that in um, uh, comments or something, but basically just Google WebGeoCalc NASA, and you'll get to this page. And what it is, it's a sort of manifold sort of tool that will give you positions, something called state vectors, for any thing that's known, that's tracked by NASA, but certainly all the solar system, sun, moon, planets of the solar system. So it also would do all sorts of fun things um, other than that. But let me just show you how I found the sun and moon positions. Um, let's start with the sun. So you want to, I don't know if you saw that, what I did there, I clicked on state vector, then choose solar system kernel. Target is the sun. Just do the exact same thing, but type in moon if you want the moon. For observer, uh, you want Earth. Reference frame J2000 for this project. Okay. Light propagation, I chose none. There's a ever so slight effect on the right ascension degree with the effect of light propagation. I chose to uh, use none for now. Time system UTC is what we want. We want an Earth-based time system. So time format, calendar, date, and time is fine. We want an interval. And the start time, if you choose the little question mark button, it'll give you some information. Like for calendar, date, and time that we're using, use strings um, and T-style ISO time can be used for only for UTC. We're using UTC, so let's use this format. Copy that, put that in here, paste it. Um, what we want, instead of this example for November 24th of 2009 at 14:21 and 33.436 seconds, we want to instead begin not in November but in January, so change the 11 to 01. We want not to start on the 24th, but rather the 1st. The T is for UTC, kind of, this is a standard time nomenclature, kind of. And we want to start at midnight. Um, so there you go. Um, Stop time. We want to stop at the very last day of um, 2017. So I'm just going to put in, it's okay to put in 2018, January 1st at midnight. Same difference as 59 seconds on the night before. And it's okay to get one extra second in there. So, oh, I forgot the T. Okay, so I would love to have it be every 1 second, but let me show you what happens. And everything else can be changed right here. The state representation, we want the right ascension, but we don't need a time series plot. So don't worry about the plot section. Error handling, stop on error is just fine. Click on calculate, and you get this error at the top, too many data points. So it'll only support 25,000 data points in a single calculation. And there's tons more than that, namely, if with what we just did, over 283 million data points. So we need to really curtail things. So what about instead of every 1 second, we do every 30 minutes? So we're really approximating the sun moon time, but sun moon degree, right ascension degree. But um, if you think about it, the sun only moves 1 degree per day, approximately. So in 30 minutes, that's 1/48th of a degree. That's pretty precise. So um, I was just thinking that this would be fine to use. Oh, that it would be okay to use this, uh, approximation. So let's see what happens then. Still too many data points. All right. So we right now we're down to 157,777 data points. There's a government sort of limitation on how much data they're going to serve you. So what I'm going to do is just go year by year, 2009, 01, 01 to 2010, 01, 01 at midnight. So calculate. Aha, now it's performing the calculation, which is great. Just going to take me a second to retrieve results here, and I'll show you how that looks. So great, we have state vector for sun from the Earth's point of view, J2000 reference frame. You can Google that if you'd like more information on that, but basically it has to do with uh, precession. Okay, so check this out. We have a date, a time, the right ascension, which is the tropical degree, astrology degree. We also get the declination and range. We don't need that. Uh, so it comes with it. Okay, no problem. So what I would recommend you do next is click on download results, and you can see, you can pull up in your astrology software the match of the right ascension to the sun's degree out of 360 degrees. It was at 281.5 degrees at midnight, January 1st, 2009, start of the day, um, in Atlanta. In Atlanta. So that means it's at 11 degrees Capricorn. Um, and the way I got that is that if these are, I do sidereal actually, so, but definitely believe in fixed houses, whole houses, sorry. And let's see, 281 is going to be 7 times 30 degrees. I'm sorry, 9 times 30 degrees um, plus 11 degrees, right? So the 9 units of 30 degrees takes us through Sagittarius and into Capricorn by 11 degrees. So that's how I got that, and pull it up in your astrology software and it should match. So you can download these results into a CSV file. I'd recommend CSV and click on download. I'm going to cancel out of this because I've already done that. For every year between 2009 and 2017, I made separate files 2009, 2010, 2011, 2012 for both the sun and the moon. I did it all once again with the moon. So great, what does that give us? It gives us a lot of data, but rounded off to the nearest half hour um, is really all the even all of that data will give us. So this is just some code to do that, to um, pull up uh, the degree of the sun and the degree of the moon to the nearest half hour. So the thing is, due to leap seconds, there's, I think in 2012 it was, that there was a, instead of like 1 a.m., it would say midnight. The file would, the CSV files that we just got from WebGeoCalc, um, it's, it would say 59:59 uh, instead of 1 a.m. And similarly 1:59:59 instead of 2 a.m. 3:59:59 instead of 4 a.m. and so on through the day. If you think about it, there's still one special case um, when this isn't helpful, and that's when you're going from 23:59:59 to 24 o'clock, and you would need to add on 1 day. So this code does not do that. So there's, for the crimes that occurred near midnight um, in 2012, there's not uh, accurate kind of sun degree or moon degree, and that's an artifact of these leap seconds and the NASA spice stuff. How they do it, they're doing it completely properly, but that means I cannot use some of the data that's near midnight uh, when the leap second was active, which was for about half of 2012. Gosh, so what can you do? I don't know, but um, this is just one method of getting the sun degree and the moon degree. Remember that I also have this going on, um, which was the original way of getting the sun right ascension and the moon right ascension. It's cooking. It's gonna take another day to get up 320,000 values this way, but I'm trying. I'm running the code, and all I'm saying is that even with this alternative way of finding the sun degree, the approximate sun degree, the approximate moon degree, there's sort of data wrangling issues. So this is, even doing it this way with the WebGeoCalc is taking like a day and a half to search those CSV files and find the sun degree, the moon degree. Okay. Um, so what's the end goal anyway? I just want to remind you what that is. That's to make a classifier based on the midheaven and the sun moon degree and try to predict what kind of uh, crime is committed, not the total count of crimes being committed, but what kind of crime is being committed. And I'll just have to wait another day in order to complete this code uh, here, from here, from this line to all the way down to this line. And what that will do is tell me how successful such a very simple astrology classifier can be. And so what do we compare it to is a fundamental question. And this part I already did, so I can show you this today in part 2. Um, First, I just wanted to use the date objects, which I'll remind you. Let's see if I have an example up here. Yeah. So, like, the very last crime was committed Sunday, the 31st of December 2017 at 11:39 Eastern Daylight Time. And that's an example of a date object where all of the date and time zone information is in one object. And I thought I wanted to just construct a very simple classifier where I just feed in that date object, assign it to a crime type based on those UCR numbers, and see if it's able to predict um, the last 20%. Like if I train it, something called training, if I train it on the 80%, the first 80% of all of those years of data, can it predict the last 20%? And this is a standard kind of question. And if something very interesting came out, um, so on this edge, you can read the actual type of crime. Um, and up here, oh, sorry, yeah, up here or down here, either edge you want to use, it's the predicted class. So what you want to see is like 110 crime predicted to be 110, 120 crime being predicted to be 120, 311 to be predicted as 311. And sure enough, out of 300, um, no, I'm sorry, 2,115 crimes that were of the 311 type, 146 were classified correctly. That's like 6% or something. That's not so good. But we would want to see this diagonal space to be lit up, to be dark in color. And there's a ever so slight coloring here where 311 was somewhat sometimes able to be predicted correctly. If you go down here into the 500s, I'm sorry, 400s actual class, there's some that were classified correctly as the 400 series of crimes. Similarly, for the 600 level crimes, quite a lot of them were classified correctly. Some were classified down in the 400s, 500s, and some of the 400, 500s were classified as the 600s. So it's interesting, but the accuracy total in total is only 15.4%, and the uncertainty is fairly low because, after all, we are looking at 320,000 some crimes. So this is one benchmark. We want to see if we can get better than that with the astrology data, which again is simply the midheaven, the sun degree, and the moon degree, and it's still cooking. So that's going to take another day to get the results. And then I thought to myself, self, um, what if we just feed in uh, the year, because like was looking at that um, data in that one graph, there is modulation across the years where there's a dampening of that umbrella format. Let me show you that graph again. It's up here. Yeah, this one. But there's a subtle sort of decrease over the years, but there's a spike in mid-year. Um, so we know there's some time dependence of at least total number of crimes. Uh, so I thought to myself, like almost I visualized like a precinct captain who, given say that it's Christmas Eve, or that it's New Year's Day, or that it's July 12th, um, has some sense of the type of crime that's likely to be committed. For instance, it looked like there was a lot of car break-ins on New Year's Day early in the morning. So a precinct captain would know that. He would, or she would, know that. Oh, it's New Year's Day, 2 a.m. I bet this call that came in, I bet it's a car break-in. So I wanted to just feed in the year, the um, month, the day, and the time. So here's day, month, year, and hour, just the hour, not the minute, but the hour of the day. And what is the ability of the computer to classify the crimes? Can it do it correctly, just like in this precinct captain kind of way? So something interesting came out, that uh, the computer chose to maximize uh, accuracy by just just choosing two possible crimes, a 511 and a 640. So let me go back to the crime date. So what was it? I just spaced it. Something. Oh, hold on 1 second. 511 and 640. All right, that's where we are. 511. Um, oh, there it is. Is forced entry residence, and um, a 640 is uh, theft from motor vehicle. So it's almost like a precinct captain who's sort of prejudiced and just wants to um, say, oh, it's probably one of those two crimes. The funny thing is that that precinct captain would be 30% accurate. 30% accurate. So this is the mark of to which we will measure the astrology accuracy. Is it better than the precinct captain, if you will? Is it better than 30% accuracy? So until tomorrow, uh, at which time I should be able to give you an answer. Um, have a have a good Saturday, have a good Sunday, and once again, hopefully on the last day of September here in 2018, I'll have an answer for you. Thanks for watching.